4.8, number 383. We have the limit as x approaches infinity of x times the sine of 1 on x. All right, so as x heads towards infinity, x heads towards infinity, obviously. And as x heads towards infinity, 1 on x, right, the argument inside the sine function here is heading towards 0, of course. And sine of something very close to 0 will itself be very close to 0. So the whole sine function is heading towards 0. All right, so we have an infinity times 0 case here, which is our indeterminate product, which we should be able to change into an indeterminate quotient and then use L'Hopital's rule. The usual game to play with a product which has the power of x in it is to write the power of x in the denominator as a reciprocal. That is, I would have the limit as x approaches infinity of sine 1 on x over 1 on x. I can't just write x down here. That would be false, right? That would not be the same as the original function, just to slip x down here. But if I slip it down here as a 1 on x, then sure, if I were to re-multiply this through here, multiply by the reciprocal, I would have x forced back up here in the numerator with sine exactly the way it was here. So this is a legitimate algebraic manipulation here. All right, so now we see that as x heads towards infinity, the bottom heads towards 0. The top we already said is heading towards 0. So this is a 0, 0 case, and we can apply L'Hopital's rule, which says take the derivative of each of these two separately and reapply the limit of that quotient. So the derivative of sine 1 on x is, the derivative of sine is cosine, 1 on x inner function stays the same, and I multiply by the derivative of the inner function, so the derivative of 1 on x needs to be appended here, negative 1 on x squared. The denominator is 1 on x itself, so it becomes negative 1 on x squared, just like the chain rule did to the inner function here. So wonderfully, these two will now cancel. Don't have to worry about them. And now as x goes towards infinity, 1 on x, the argument here is still heading towards 0, but that's not a problem for the cosine. The cosine is going to head towards 1, and there's nothing else to compete with it, unlike up here when this was heading towards 0. The fact that the x factor was heading towards infinity was a competition between these two. We didn't know what was going to happen, but here we know exactly what will happen. The whole cosine function here will head towards 1, and there's nothing else to deal with, so the answer is 1.